Hey guys, welcome to Mastering Solutions, where we're taking the stress out of your science classes. This question says we have two gliders sitting on a frictionless track, and one is attached to a spring at rest. So let's go ahead and label this one M1, and this one we'll say is M2. M1, they say, is 700 grams, which is 0.7 kilograms. And it's at rest, so its velocity is 0 meters per second, of course. Then they say the spring constant, the spring, is 7.5 newtons per meter. And then they say M2 is 350 grams. M2, 350 grams, or of course 0.35 kilograms. Okay, so then they say the M2 slides over and pushes the first mass, or the first glider, and the spring, and compresses the spring some distance. And then it says, what is the amplitude of the oscillations, and then what is the period? Well, V2 first is 140 centimeters per second. I'm going to put that in standard units, so I move it over 2, so we have 1.4 meters per second. All right, so now what we need to do is first we need to figure out how much kinetic energy we have. And so then we're going to figure out how far the spring gets compressed. But first off, before we do that, we need to figure out the final velocity of after M1 and M2 smash into each other, so we can figure out how far did the spring get compressed. So what we're going to do is use a conservation of momentum. So we know that P1 plus P2 is going to equal P1 final plus P2 final. But they tell us that the two masses smash together and stick together, so let's rewrite this as P1 plus P2 equals P3. P, of course, momentum. We can break that up now as mass times velocity plus mass velocity 2 equals mass velocity 3. All right, so now we can find the final velocity of after they hit together, and that will be then our initial velocity of compressing the spring. So now we can simplify this just a teeny bit more as well. M1 is at rest, so its velocity initial is 0, making this whole term 0. So now we have M times V of 2 equals mass of both of them together times their final velocity. So I'm going to rewrite it over here. So M2 is 0.35 kilograms times its velocity of 1.4 meters per second. And then we're going to divide both sides by M3. So now the M3's cancel. So we divide all of this by M3, which is 0.7 plus 0.35 is 1.05 kilograms.
So V3 is equal to 0.467 meters per second. And so this makes sense because we're adding a lot more mass to it. So it makes sense that it'll be slower than it started out with, just because mass 1 wasn't moving at all. So it's slowing down the whole two masses together. So now we can use energy conservation. So what we're going to say is now we're just going to look at the spring, and we're going to have some kinetic energy plus some spring potential energy, and these are both initial. And that's going to equal some kinetic energy final plus some spring potential energy final. So we know, because we've talked about it in past videos, that when we oscillate between 2 points, I'm not going to draw the mass, I'll just draw the equilibrium point, the amplitude, and the negative amplitude. That at A, we are all at spring potential energy. At negative A, we're at completely spring potential energy. And at the equilibrium point, we have our V max, or completely kinetic energy. So we're just going to look at 2 points. We'll look at either, let's just say, let's say the equilibrium point and the amplitude. So if we start at the equilibrium point, that means our spring potential energy is 0, and then it'll oscillate out to A or negative A, it's the same. And so that means we'll only have spring potential energy, so our kinetic energy is 0. So now the kinetic energy of the two of them together is equal to the spring potential energy. So we have 1/2 mv max squared is equal to 1/2 k times delta x, or the amplitude squared. Remember, the amplitude, is going to be the same as how far the spring is compressed. So that's why we changed delta x to a. Okay, so they want, what was it that they wanted? They wanted what is the amplitude, and then what is the period. So let's solve for a.
So both terms on both sides of the equation have a 1/2, so let's cancel out the 1/2. So now we're left with mv max squared is equal to ka squared. So now we'll divide both sides by k. So now we're left with, let's come over here. So now we're left with mv squared over k is equal to a squared. Square root both sides. And now we have a, where the amplitude is equal to the mass times the velocity squared over the spring constant square rooted. Let's scroll up and plug in our values. So a is equal to the mass of both of them, we said was 1.05 kilograms, times the velocity of them squared, we figured that out, was 0.467 meters per second. 0.467 meters per second squared. Then over the k value was 7.5 newtons per meter, and then we want all that square rooted. So we get an a value of 0.175 meters, and I think I might have had some rounding stuff in my calculator, because for mastering physics it rounded it for me to 0.17 meters, even though I had 1.75, should be 1.18, but whatever. So 0.175 meters is how far the amplitude is. And now we need to figure out what the period is. So T for period, we have the mass of everything and we have the spring constant, so let's use 2 pi times the mass over the spring constant square root. And we have all these values, so T equals 2 pi. The mass is 1.05 kilograms over the spring constant, 7.5 newtons per meter, of course, and then square root. So the period is equal to 2.35 seconds, or rounded 2.4 seconds. If this video helped you out, please hit the like button and subscribe. We'll be coming out with more videos for your homework every single week, and thanks for watching.